In this video, we're going to look at topic 67, example 4, where we use graphing technology to solve equations. So in the previous videos, we used the graphing calculator to find intersection points. The first two videos, we were really just looking based on kind of the eye test and finding numbers, finding solutions. In example 3 video, we were using a table to find approximations. And in this video, we're going to continue to use a table and a graph to come up with we're going to use a table to draw the graph by hand, and then we'll use the graph and something called the intersect feature to find the exact solutions, all right, or as accurate and exact as we can get. So I'm going to enter in my plot points here. They're not cooperating with me. I'm going to close this out. Let's try this again. Let's see if we can use Y1. Not let me use Y1, so we're going to have to deal with it. All right, so for whatever reason, this kind of comes up every once in a while, but we will manage. All right, so under y2, I'm going to type in my quadratic equation. I'm going to type in negative x squared. Do be very careful that you use the negative symbol, not the subtraction symbol there, plus 8x minus 13. So the first phase of this, the first stage, is I'm going to try and come up with, use a table to get some points to graph this. And then I'm going to change this one. I'm going to use the green one. Green one is close enough to blue. So we need an absolute value. So I'm going to, remember, hit the math key, scroll right to the number list, and then select option 1 with ABS. There's a chance that your calculator uses parentheses here. It'll say ABS parenthesis. You're treating that ABS parenthesis as the absolute value, so you'll still be able to type it in. So x minus 4. All right, and what I'm looking for is I want specific points. So I'm going to go to my table. But remember our last video, we changed the table settings. So we're going to hit second and go to our table set. And we want to change our table start. We're going to go back to 0. And our table change, the change we just want as a 1. All right, so that'll give us specific points that we can work with. So second table, and now we can match up points and we'll be able to graph. Make sure you're careful with which one you're using. You know which one you entered as Y2 or Y1 or Y5, whatever it is, so that you don't make any mistakes. Graph them one at a time so that you don't, again, make any mistakes. So my x value, when I have an x value of 1, my y2 is negative 6. So I'm going to plot the point 1, negative 6. We're going to put that in red. That's off my graph, so I'm not going to use that. So I'll start with 2, negative 1. We're going to plot that point right there. And then I'll keep going from there. 3, 2. So 3, 2. 4, 3. Which looks like that's going to be my vertex. 5, 2. 6, negative 1. And then looks like 7, negative 6 is off our graph, so we're going to stick with that. So I'm going to draw this parabola here. The nice thing about this problem is that one of them is a parabola, one of them is an absolute value function. So it'll be pretty clear which is which. You do want to be careful though. Occasionally you will have 2 parabolas or 2 linear functions or 2 absolute value functions. So you want to make sure you're very careful with which one is which one on the table. All right, so now let's graph the second one. You're actually not going to need the second graph. This was here for if we were doing this a different way. We're not going to have to worry about that. So the green one, I'm going to do the same thing. I'll go to 0. So 0 matches up with 4. So I have 0, 4. I actually probably can go up a little bit and see what negative 1 matches up with. Negative 1, 5. Negative 2, 6. So I'm going to plot pretty much every point that I can. Really, we're just looking for the shape of the graph. So 1, 3. But the more points, the more accurate your shape will be. And then really you just need to figure that out. So 2, 2. Some of you may feel like you need more points. Some of you will feel like you need less. So 3, 1, 4, 0, 5, 1. So now we have our vertex where it changes direction. and I'm just going to fill out the rest of it. So I wind up with something like this and this here. All right, so I have two solutions. I have a solution right here, and I have a solution right here, right where they cross. So it's somewhere between 2 and 3, a little bit closer to 3, and somewhere between 5 and 6, a little bit closer to 5. Now, previously, in the last video, we used our table, right, and we changed our table settings to find our solutions. That's not going to be the case this time. This time we're going to go to our graph, so I'm going to just hit the graph key. Make sure my graph looks like what I've drawn, which it does. So yours will be in black and white, but it's the same idea. And what we're going to do is we're going to try to find the intersection points using the graph and make this as accurate as possible. So what I want to do is I want to calculate something. So I'm going to hit the second key and then the trace button, and in blue it says calc. So we're going to select that. Now for these, I'm looking for intersection points, right? I want to know where the two functions intersect, where they cross. So I'm going to scroll down to intersect and either hit the 5 key or hit enter while 5 is highlighted. So we'll select 5. Now you'll see it says first curve. What you want to do is you want to hit the right or left arrow keys until your cursor appears on your screen and is on one of your curves. It doesn't matter which one it is. In my case, it could be the red one or it could be the green one. It doesn't make a difference. But you're going to make sure that cursor is on one of the curves, and then you'll hit enter. That tells the calculator that that is one of the curves you're looking for an intersection point. So I'm going to hit enter there. Now it's going to ask for a second curve. Your calculator should jump to the other function, in this case the absolute value one, but if it doesn't, you would hit the up or down key, and notice when I hit up or down, it'll jump from one to the next. All right, and again, I can scroll left or right to move the point, but it doesn't matter as long as I'm on that curve. So once again, you'll hit enter, and now it's going to ask you to guess. We're not trying to guess a solution, but one of the things that you can do is you can scroll and try to get as close to the intersection point as you can. All right, in that case, it's about there. So now I'm guessing that that's my answer. I'm going to hit enter. And now you have an intersection point where x is equal to 2.6972244 and y is equal to 1.3 and so on. So our solution is that, right? We just care about the x value. So we're going to say that x, and we're not going to say equal in this case. We're going to approximate again because we don't want to write 7 or 8 decimals. So I'm going to say that x is approximately 2.7. I'm rounding up a little bit here, but you get the idea. This option is usually a lot easier than the table option, although it takes a few more keystrokes. It's a little bit more accurate. You'll get a better answer every single time using the intersection feature rather than the table feature. So x is approximately 2.7 at that point. All right, if you want to say 2.697, that's fine. Usually they'll tell you what decimal place to go to. They actually did, and I forgot about it. They said to the nearest tenth. So 2.7 is good for this problem. Now, what we need to note though is we do have two solutions, right? So we got to figure out the other solution. Using the calculator, you're going to do the same thing, but this time, what you're going to do is you're just going to put the guess key a little bit closer to the other intersection point. So I'm still going to hit second, trace, which will bring me to the calculate. I'll then go option number 5 where I intersect. See my cursors on both of them. I have to be careful here, so I'm going to scroll over and make sure that I'm clearly selecting the parabola. So I'll hit enter. My second curve, again, I'm going to clearly select the absolute value, so I can hit enter there. Now this time, what I want to do when I guess, I need to scroll over, and I can't leave the cursor here. I need to put the cursor close to my second intersection point, and I'll show you why in a second. But once you're close there and kind of hovering over it, you can hit enter, and notice that it's going to tell us that our intersection point is 5.3 with a bunch of decimals or a bunch of numbers after, and y equals 1.3 with a bunch of numbers. So we're again going to say that x is approximately 5.3. right? And that's our second solution. Now, here's why you have to be careful when you're selecting the guess and you're moving the cursor. I'm just going to draw a really quick sketch of this, but let's change colors. Let's just put this purple. So if I have this here, let's say I have some kind of solution here and a parabola here. Wherever I put my cursor for the guess, so let's say I put the cursor here, pretty much what the calculator does to solve for it is it starts at that point and it just does a spiral and it keeps spiraling until it finds the intersection point. So whatever intersection point it hits first, that's the solution it's going to give you. So if I don't move the cursor close enough to this point over here, I'm never going to get the solution for that. My calculator is just going to keep giving me the solution that I might have already found. So it's important that you learn how to move the calculator, the intersection point around, move that cursor around when you're guessing, and make sure it hovers over the intersection point that you are looking for. All right. Hopefully you're happy with this video compared to the other ones because this is far easier to find the intersection points. You're still going to use the table to find the points so that you can create the graph, and you're going to draw the graph by hand. However, the intersection feature or the intersect feature is going to give you the most accurate solutions. Way better than trying to pick it out by just using your vision, and usually much easier than using the table. All right, and that's it. Again, we didn't need this here, so you can ignore that graph there. And that's it for this lesson.